In this demonstration, I'm going to show you using and configuring Red Hat Service Interconnect using Podman sites. So this means I'm going to be using the full power of Service Interconnect across different data centers without using any Kubernetes or OpenShift as part of this demonstration. So to show you the architecture of the demo and give you an idea of what we're going to do, we're gradually going to build up this picture. So we have an environment that we call Demo Lab that runs in an Intel data center down in Swindon, and everything running inside of that runs inside a VPN. We then have an AWS cloud environment, and inside that AWS cloud environment, we have a private subnet, and that's running two key services that I need to integrate with my superheroes application that's running inside of the Intel data center that we call Demo Lab. So just a little bit about the application. So the application inside a Demo Lab has a user interface. So that's where we'll see everything start happening. And I can show you that user interface right now. So the user interface is here. And then if we refresh this screen, we can see that what it needs to do is get information about heroes, and it needs to get information about villains. And then we allow the heroes and villains to actually have a fight, and we record who won that particular battle. This is a modern application, and as we can see, it's got circuit breakers in here. And so at the moment, it's not showing any heroes, just a fallback position. And the same is true with our villains as well. So what we need to be able to do is to fix that up. Just as an aside, we also have inside the hero service a user interface. So we can directly interact with that if we choose to. And so at the moment, we can see that's not working. So hopefully going through this process will fix that up too. And so back to the slides. So to facilitate this and to make this happen, we don't want to open up any inbound ports in our private subnet. It's important that we protect those. These applications running on this side are running inside a VPN. And of course, we want to honor that VPN as well. We don't want to connect in any other way back into this data center other than using its VPN. But we don't want to create connections to that VPN on the outside here. So to make this all happen, we're going to use a public subnet, basically a DMZ running inside of AWS. And into that public subnet, we're going to install a virtual machine where we will be running Service Interconnect. And so ultimately what we're going to do is we're going to run Service Interconnect in the public subnet. We're going to run Service Interconnect in the private subnet. And then we're going to run Service Interconnect in Demo Lab as well. And then we're going to connect these all together and hopefully make this application start working. So the first step along the route is to install Service Interconnect site into the public subnet. So let's go ahead and do that. So if we come into here, we can basically install using the CLI called scupper, and we can do a scupper init. We're going to give the site a name, AWS public, and the ingress host for this one is the public DNS or IP that we're actually going to use. So that means things on the outside can establish a connection with it. So we will do that, and that will just take a few seconds to get itself up and running. And once it's up and running, we can then do scupper status. That enables us to check that it's all good. So we can see that we've created a scupper site using the user EC2. It's called AWS public. It's running in interior mode, which means it can accept connections and do routing from others. But at this time, it's connected to nothing and it's exposing no services. So the next stage is to do a similar activity inside of Demo Lab and a similar activity inside of the private subnet. So let's go ahead and do both of those. So inside of Demo Lab, we will do a scupper init. This time we're going to call it Demo Lab, and its ingress host is a local DNS name called scupper router. So we'll do that, and then we can do a scupper status. And we can see that that looks very similar to the one in the public in that it's been enabled by me, the user. The site is called Demo Lab. It's in interior mode, and just like before, no sites or no services connected at this point. And we'll do the same thing inside of the private data center, or subnet, I should say. So let's just do that, and we can do the same thing, scupper status, and all looks good with the world. So it's created, it's AWS private, interior mode again, and it's not connected to anything at this point in time. So the next stage is to now create a mutual TLS connection, which is bidirectional between these two sites. And so when we create this connection, we have a mantra that says we need to connect from the most private to the most public. So this guy being behind my VPN means that this is the most private, and I'm going to create a connection from Demo Lab to the public subnet. So let's go and do that. So we have to do this in a couple of stages. So the first thing is we need to get a token from the public Service Interconnect site to enable us to establish a connection. So I've done scupper token create, and we've written that to a YAML file called aws.yaml. So if we cat that, we can see that it's a file with a token inside of it. That token enables us to get a certificate to enable MTLS connection. And you can see it also has all of the connectivity information that it requires to establish that connection. So we can copy that out because we need this down in both the private subnet and inside a demo lab. So let's copy that. Now I've done this previously, so I'm just going to delete the one that's already there, and let's do a new one. And then we will insert that into there, and we have it. And just so we can do it all in one go, we'll do the same on the private side. So let's go there and viaws.yaml, and we'll pop that in there as well. So we've now got the token required to establish a connection on both sides. Let's just clear that so we can see what's going on. And clear that as well. Okay, nice. So to establish the connection, we need to use that token. We're going to do the one in Demo Lab to start with. So we're going to do a scupper link create. I'm going to give it a name, Demo Lab to AWS, and we're using that token that we just copied from AWS public. Okay, that's done that. So we can now do scupper link status. And we can see that according to Demo Lab, it's now successfully connected to AWS public. But let's just do a scupper status here. And we can see quite rightly, this also thinks it has a connection from one other site in it as well. So the next stage is to do the same thing, but from the private subnet to the public subnet. So using that same mantra of most private to most public, I will and should be connecting from the private to the public. So I'm not requiring any inbound ports to be open to establish that connection. So we come to the AWS private side, and we again do a scupper link create. So scupper link create AWS private to AWS public using that same token. Okay, so that link should be established, and let's just make sure that is the case. So scupper link status. And we can now see that we have AWS private to AWS public is connected. So just by checking scupper status here again, we should now see that we have two sites connected here. Now, something really interesting has happened at this point as well. So if we do scupper status on this side, only connected to one site. However, it now thinks it's connected to two sites. So it's connected to two sites, however, one indirectly. So there's a connection being established through the public site through to the private site. That's interesting. And that, in theory, means that I should be able to talk and send TCP requests across non-routable networks now from Demo Lab into the private side. That's interesting. So let's just do the same thing on this side, scupper status. And the same is true here. So it too is now connected to two sites. Physically, it's only connected to one site. Logically, it's connected to two, with one of them being indirect again, coming through this public site. So that should mean that because we've established bidirectional connectivity, I should be able to talk from Demo Lab to AWS Private, and I should be able to talk from AWS Private across to Demo Lab. So through the rest of the demonstration, we'll try and prove whether this is possible or not. So the next stage is we want to make the villains service accessible to this fight service, so we can start to see some information appearing inside our user interface. So let's give that a go and see what happens. So we're going to expose this to the Service Interconnect site, and to do that, we have to run a scupper expose command. And so we can do scupper expose. And we're doing that in the private side. So what we want to do, take you through this, scupper expose the host IP address. So this is the IP address inside the private subnet of where the villain service actually runs. We're going to call it inside of Service Interconnect REST villains. We're exposing on, we're trying to call at port 8084, and through Service Interconnect, we're also going to target port 8084 just to keep things simple for me, but we could change those ports if we wanted to as we went through. So that's that done. So if we now do scupper service status, we should now see that exposed through Service Interconnect is now a service that we've called REST villains at port 8084. And anything calling that will target this particular host at this particular port and make the call for us. So the next section of this now is to make that service available as a sort of proxy in the demo lab side. And so we want to create that proxy so there is a physical IP and port that this fight service can talk to, that then will pick that service call up and route it across TCP all the way across to this side for us on the right hand side. So to do that, we do a service create. And so we can do service create. Oops, sorry, that's my mistake. That's a copy and paste error. Get rid of that. Okay, so we can do a service create REST villains. So this REST villains has to match the REST villains over here and the port 8084. And we're going to expose that on this side as a host IP of 10.50.1.127 and host port 8084. So the local services will talk to this to actually make the call and not anything to do with the remote IPs. So let's just do scupper service status on this side. And we can see that we now have REST villains on this side with a host port that we're exposing, but there is no target. And so what that means is that it has to be picked up by Service Interconnect and use its own routing tables to actually identify where that target is within the system and then make the call on my behalf. So let's just check to see if that's actually worked, because in theory, we should have done that now. So if we now do new fight, sure enough, we are now talking TCP to that private subnet, calling the villain service without exposing and opening up any ports to make that call happen. And also my system here has no concept or idea of where that actual villain service is running as well. So we've created portability in the sort of service network layer as well, which is a pretty cool thing. All right, so what we want to do now is almost the same process, but we want to do that for the Heroes service. Well, not almost the same process, the same process. So we're going to expose the Heroes service out to the Service Interconnect router. And to do that, we will basically do a scupper expose of the Heroes service. So let's go on to the right-hand side here. Scupper expose. So again, the IP or DNS of the Heroes service, its address that we're going to call it inside of scupper. The port we're going to make it, or we're going to call, I should say, and then the target port we're going to expose through Scupper and Service Interconnect. So we do that, and then just as we did before, if we do Scupper Service Status, we should see something very similar, but this time for REST heroes, with clearly a different DNS with a different port mapping that's been made there. So the next stage of this is to do, again, similar thing, to create the proxy side to enable the fight service to be able to talk to that. And so we do that by doing the create service on the right hand side. So Scupper service create REST heroes 8083, and we're going to expose this inside a demo lab at this particular IP location and this particular port. So again, just as we did before. So let's go Scupper, select Scupper service status. So just as before, we now have a REST heroes created at this particular IP with that particular port. So let's test that out. So if we do new fight, we can see we're getting villains back, but we're still getting our circuit breaker for heroes. Well, that's interesting. What's going on there? Let's try the actual service. So we can try the service, and by the look of it, the service is now available and we're actually doing something with that service. However, if you recall, we did say that its database is on the demo lab side. So if you look into the application log, you'll see that it's not actually connecting to its database. Hence, we still see the fallback position in terms of the error. So what we need to do is basically expose this database across the Scupper router as well. So we've moved from just exposing sort of HTTP service to things that really listen on TCP. So things like databases, messaging queues, Kafka, all those type of things that are listening into those environments. So let's see if we can do that. This time we're going to do the expose in demo lab, and we're going to do the service create in private subnet in AWS. So we're doing them the opposite way around in effect to what we've done so far. So let's go back into the demo lab, and what we want to do is actually expose the database. Now, hopefully this will come as little surprise that the process is exactly the same. So what we're going to do is Scupper expose a host, which is the database host, the address, we're going to call it HeroesDB, and the port, so we're running a Postgres database just using default config. So the port is 5432, and we're going to target 5432 in Service Interconnect as well. So we expose that. So if we now do Scupper service status, we should see now that we've got a HeroesDB exposed, and it has a target. So that means that this side is the caller, basically. It's actually going to make the call for us. So just as we did previously, we also need to create the service on the private side. And so Scupper service create HeroesDB 5432, host IP that we're exposing at, and port 5432. So again, this side has no concept, no visibility of where that database is actually running, or the IPs that it's running at, or anything like that. Yet we're going to issue TCP calls to that database, but those calls will be targeted at this particular IP location and port. So we do that. So Scupper service status, as we've done previously, we can now see that we've got a HeroesDB that has its host that we can talk to, but there is no target. There is no definition of where this thing is running, and so we don't know. So what that should mean is now we've done that connection, at least, in theory, we should now be able to have our fights. So let's go do a new fight, and sure enough, we've now connected demo lab to the service running in the private subnet in AWS, but we've also now connected the private subnet in AWS to a database running in demo lab and issuing SQL calls to that. So that's interesting. So these things can now start working, and this application is all working and hanging together. What we should also see is that this service, because it looks like it's working, so yeah, sure enough, we can start to see that this service is actually working. And just to try and prove this point that it really is doing what I'm suggesting it's doing, here that I've got a connection directly to the database that's running in Demo Lab. So I'm VPN'd in to Demo Lab, so I've got that connection to be able to do this. So if I put a name, for example, here for another name for Chewbacca, and we actually save that to the database. If I then come here and filter for Chewbacca, we should see that its name is now Phil. If we were to change that to Phil Prosser, for example, rather than just Phil, we can see that this stuff is really accessing that database directly and doing stuff. But just to prove the point even a little bit stronger, if I come back to here, put into what we've set up, I've set up the Heroes DB to be available at this local IP running in the private subnet on that particular port, even though it's remote. So if I'm really doing what I say I'm doing, then I should be able to use any tool to connect to that database remotely. So I should be able to use pSQL since we're Postgres. So let's try it. So we're going to issue a call to pSQL database, Heroes database, port IP 10.0.141.78, and by default port 5432 using the username of Superman. So let's try that out. So let's see what happens. So yep, sure enough, it looks like we're lovely and connected in there. Let's try issuing some SQL calls to the data. So if we do select everything from the hero table, it's working. We are accessing that data directly. If I look for Chewbacca, as we were doing before, there it is, it's got Phil Prosser in it. If we were to change it back again, just to prove the point, back to Phil, issue that call again, it's now Phil. So we have now established TCP connectivity across non-routable networks in a very easy, powerful, secure way using Service Interconnect. One final thing is Demo Lab is behind a VPN. If I detach myself from the VPN, what we will see is that everything here has now stopped working. I can't type anything inside a Demo Lab. If I try and query the database, I can't get any data from that database because it's just going to sit there and hang because I've killed that connection. However, over Service Interconnect, we can still work because we use that bi-directional connectivity through connecting most private to most public to establish that connection. So hopefully that shows how we can connect different services, different databases across TCP, across non-routable networks in a really secure way using Red Hat Service Interconnect. Thanks for your time and I hope that was useful.